like, I haven't saved your number, so I'm like, wait, who is this? She said it was Melissa.
I saved all of your names. I went first name, last name, and Pepsi's biostats. So then when I made the group, all I had to do was go biostats quick, biostats quick, biostats quick, biostats quick.
Mm-hmm. That makes it easy. Well, I started the recording though.
Well, was there any questions, or do you just want to start the quiz?
I think we can just start the quiz. Is that her?
No, that's all of your texts now coming. I shut it off and turned it back on.
Oh, there you go.
If I know that somebody's there, like, did you get my text message? Did you get my text message?
Oh yeah, hang on.
It's just like I gotta reset my phone 1 second, and then I turn back on and. Yes, I did. 20 minutes later than they were supposed to, but you know. And I think my phone kind of gets messed up a little bit because in the middle of Victor, the tower, there's a couple spots where the Sprint service completely stops, even though it says you have service. Mm-hmm. You can't get internet, you can't send text messages, you can't get text messages, you can still do phone calls, but everything else, nothing.
Oh, you have Sprint?
Yeah, and then I come out of Teton Valley and come around and I cross into Newdale, and then I get like a bunch of duplicate messages, or I don't get some messages, so I have to shut off my phone, turn back on, it's like it resets to the towers over here. I just need to get a new phone.
I just bought Google Fi, this phone, and it uses T-Mobile, Sprint, and US Cellular, something that no one's ever heard of. I really like it so far.
Quiz open. Okay, question number 3. Come on, area. I need to see everything. Oh, great.
So this equals 1.358. So not below it or above it, but in the middle. 0.8255. 0.825. Or 0.826. Yeah, I didn't quite round it. Wait, that is to the right of z equals. Oh, the outsides. I'm an idiot. 0.175. Yeah. Great question. That's why I'm rubbing my eyes and I need to go home. What? Oh, 0.175. So not the big inner part, but the outsides. Here, so the question says to the right of z equals positive 1.358. To the right of it's right there. And then to the left of, where'd it go? Of negative 1.358, which is right there. Yeah. Which of the following will have a smaller standard deviation? If
Smaller standard deviation? What do the following percents? Isn't it? Wait. The small standard deviation is like the closer the data is.
Mm-hmm.
So the sample means, I think, is that what you said? Yeah, I think so. Because that would make sense because the sample mean is.
Oh, I'm thinking of z-score. No, I think you're right. Because I've noticed that the z-scores are usually more radical or larger than like a smaller sample size. But that's because, you know, it's a much tighter window. That makes sense. So no, I think you're right. It's the distribution of sample means. What does the line above x mean? Forgot.
It just changes the here. So, little line, oh, sorry, little line, oops. Oh, that's, oh, wait, not this one. The little line above there. I found it. Can I close it? Unclose it. I thought that it was. I think it's a something. Yes, there it is. Yeah, the little x with the line is the sample. And then the awkward view is.
Oh, the spread in.
Yeah.
But that was like the central limit theorem. Usually talking about the shape of it.
I think the sample length decreases as the sample size increases.
It's the central limit theorem.
Yeah. Yeah.
Yeah, I was on the right track. .045. Yeah, 0.148. Right. Ah. Oh, hit me in the head. How are you gonna find the mean?
We have to. We just have to.
Unless, oh, I'll find out to make sure it's not like a different mean.
You guys got one.
Number 8.
60.
Oh, you guys are.
160 is the mean?
I think so.
1 second.
I'll find out.
Okay.
149 is an outlier, so probably. $800 divided by 5. Yeah, you're right. It's 160.
Okay.
Was it already 160? Like, yeah. Well, no.
So what's the?
Standard deviation.
It
It should be the same
You think so?
from the last example. A sample from the last
Yeah.
question
Oh yeah.
or the last 3 questions. Oh, wait a minute. We're supposed to.
So it's.
We use 8.8.
Yeah, let's use that.
Standard deviation. Oh, gosh. So it's a normally distributed curve, so it's going to be normal shaped. Not that we're trying to figure that out, but so the z-score, 160 minus the mean. Oh, wait a minute.
I get negative 17. Hmm.
160 minus 150.8. So 160 minus 150.8 divided by 8.8 over the square root of 5. Right?
Oh my gosh, yes.
Number 8.
What do you get for number?
8.8 divided by the square root of 5 equals 3.93547. I'm going to get it now. 0.2. I got 2.33.
Let's see.
2.338. Sample mean, I believe, was the same as the population mean.
Yeah, it's 2.33, right?
Yeah, 2.338.
8, yes.
Yeah. Yep.
Isn't 8 and 6 the same?
No.
No. Because the number is 8.
Because 6 is just asking about finding the z-score of the population, like the population as a whole. But we took 5 scores from that, so we have a smaller sample from that larger population from number 6, if that makes sense.
So it's asking for the
So-
standard deviation becomes the standard deviation for the population.
for
Yeah.
the sample instead of the actual population. Is there a marker in here?
I don't see one today.
Gosh, I was
I just need to bring mine. I have some.
gonna
Okay,
teach you.
so it's the, regular, it's the,
So it's the same formula, except in the denominator. You know how for number 6, for example, it was 160 minus 150.8 divided by 8.8. But when you divide 8.8 from that, you take, before you do that, it's 8.8 divided by the square root of 5. So when we take,
Because we're in this one, number 8 is asking for the sample of 5 students.
so the formula for finding the z-score is the same, except for a sample, we also have to divide the standard deviation of the population size by the square root of the sample size that we're taking. That makes sense. So let me show you.
so it doesn't look, so it looks like this. It looks like this.
Yep. So the standard formula for it is z-score equals the number minus the mean over the standard deviation over the square root of sample size.
Oh, you found a marker. Oh, perfect.
Does that make sense?
Yeah, okay, so.
Because
so-
like
'cause we
regularly it would just be z equals n minus the mean over the standard deviation,
Uh-huh.
but then we're adding that.
And we did those, not this last lesson, but the previous lesson, this, right? Did we ever use that?
I don't think so.
No, I think this is
This
the
is
first
new to
time.
today.
Yeah.
Okay.
Yeah.
Okay, all right, so. And then what did you guys get, just to make sure that I.
Did you work it all out? And then we'll tell you after you work it out. Pause the quiz.
Okay, so.
Melissa says she's here.
Not here.
He's here?
No. In our first. Which is,
So for the next one,
Which is
for number 9, we just take the standard deviation that we just found out, plug it in, and then shade in the area above it, the right of it. So, probability is using the applet to find the area. So I think we just plug in the z-score that we just calculated for number 8.
2.33, and it's a golf.
Yeah.
So I get like 0.009.
Yeah, me too.
But it's gonna be 0.
009, because it said 4 decimal places.
Oh,
So we write down that whole number.
okay. Awesome.
Coincidentally.
Nice.
Oh gosh, I just did this.
In the homework or something.
Yeah, the
you
videos.
guys did 2.9.
Yes, that is it. You got it. Now you just take that z-score, plug it into the applet for the next question.
Hello.
There you are.
Passed by earlier, but I'm saving you for student support.
Oh, no, that's not us.
Okay, it's kind of been an off day for everyone.
Sorry, I'm so late.
No, you're good.
We've already started the quiz, you can go ahead and just start it and then we can.
We're like almost done too. So we can tell you everything.
Yeah. Okay, let me catch my breath.
Okay.
Next week is a test.
Next Friday?
No,
Wait,
not-
test?
Like by next Wednesday.
No, is it-
Yeah, it's due Wednesday.
That's our.
I know, isn't that weird?
Yeah,
Yeah,
we have
that's a problem. Oh.
I didn't know that.
So this is.
It'll be our first one?
Mhm.
Okay. I already missed homework because I forgot it was due Saturday.
Not normal. Oh, as in like, I'm sorry, I'm talking about the quiz. I just had to say that out loud.
What is the shape?
Left skewed?
Or is it normal?
It's not normal.
Because the man is 81. So it means that it's more than 30. And,
Is that the rule?
yeah,
Okay.
but I'm not sure because it says that it's left. So.
What is the shape of the sampling distribution of the random variable? Because it does say it is left skewed, but yeah, the sample size is 81.
It's large. So
It's a large, yeah, approximately normal. That should be the answer. If it's not, I'm gonna punch a wall.
For number 9, you get 0.0114. What did I misunderstand? Which one?
0.0097.
You work at the plasma donation center?
Uh-huh.
Evil place.
Do you ever donate?
I haven't been able to. Almost passed out at the blood typing.
Oh, really?
And I don't even faint at the sight of blood either.
But when it's your own, it's a different ball game.
Well, no, my own, I'm used to it.
For me though, what gets me is when when I watch them collect it in a tube. I don't know, it's just that image that gets me.
Yeah, it might be it too, having way too many surgeries in the past.
Oh, I'm sorry.
Yeah. No, it's fine. Or it just might be me because I get lightheaded sometimes.
Human stuff bothers me. Animal photos.
Wait, do you understand number 11?
what is the man who's means?
Oh, I get it. It's the same mean that was given to us. Remember? Because especially if it's a large sample, it's going to be the same mean. So it should be 3.5.
Okay. Oh. Oh.
Yeah, it says round your answer to one
Yeah.
decimal place.
Okay.
You have done the video.
Hmm?
The video.
Oh, I did. I just forgot that part.
So that's pretty complicated.
So 0.7 divided by the square root of 81, which is 9. 0.7 divided by 9.
I remember this one.
0.07. Standard deviation. 0.078. Distributions.
Okay, less than.
Less than 0.3. So it should be 3.3 minus 3.5 over 0.078. And then you plug that z-score in.
3.3 minus 3.3.
5.
Yeah. Okay. 5. And then, wait, that's 0.6. And it's next, and
Will be less than 3.3. So it's going to be smaller than it. Did you get negative 2.64? So it's 0.0052. Round your answer to 3 decimal places.
what's your answer,
0.00.
Sean?
Will be less than 3.3.
So what do you get in the outlet? Like,
Was that your z-score?
so
Because it is a right skewed. The mean is
So what-
3.5.
no, yeah, you're right.
And then a large,
Yes.
the same standard deviation
Yes.
that we just
Mhm.
calculated.
Okay, I'm not understanding probability, guys. It keeps asking these ones about probability, and I'm not understanding what it's asking.
Okay, so you know how to find z-scores.
Yes.
And when you get the z-score, you plug it into the applet, and then the area up top is going to give you the probability. As long as you highlight certain areas of the applet correctly. If that makes sense.
So it's 0.00.
So I'll have to, now that we have a marker, whiteboard.
Well, I tried that. So
Here, I got 2 questions and then,
I'll just keep looking.
no, and then I'll teach you.
'Cause, yeah, I'm understanding.
Input the number, get the number on top, and that's the answer.
For the,
Mhm.
so for like 13, okay, well, I have skipped all the probabilities because I haven't realized that.
Same thing.
But
Yeah, and then you just shade above it. So 0.995. Excuse me.
okay, so for 14, what it's asking is you do that equation that we were using before, but it's asking for the probability, not the z-score. So it's not asking for the answer that I'm getting from the equation. It's asking after I get the z-score and I put it into the,
13 and 14. Literally, you just shade in the opposite region for 13 and 14.
we got 0.078, right, for the z-score of 13. I mean, 13, 12, yes, 12. 0.078. That we got for 12.
For number 12?
Yeah.
Yeah.
So I have the right numbers.
What does it mean by what results implying that the spread of X decreases as the sample size increases?
Which number is that?
Central.
Is that 3? No, 4.
It lists normal distribution, the 65 minus 99.7% error.
Remember, in other words, it's basically talking about the more data you get, or like the greater the sample increases, or the more the sample increases, the taller the curve get, essentially. I'm not even talking here. The taller the curve gets, essentially. What's that?
The bigger the numbers, the lower the curve.
Which question are you on?
Sorry.
It should be, I think it's like the larger the data set,
Yeah.
the more normally shaped
Yes. That's right.
the curve.
Question
So that would be the central limit theorem, which is the answer.
So the central is talking about the shape.
I'm just gonna go with it because I don't know what any of those are.
Were you able to look at lesson 6 on your own at all?
I was only able to skim through it because I didn't have
Okay.
time.
That was one of the things that was talked about in lesson 6 a little bit. Okay, so now. So find the probability and determine the sample effects of this procedure.
So the central limit theorem and law of large numbers were taught together in the last lesson. And the law of large numbers, we're going to do that first, is basically stating that the more data points you have recorded, the more likely it is to even out. That's kind of a vague definition, but think of it as like, say you're flipping a coin. You only have 2 options, heads or tails. So starting out, you may have flipped tails like 20 times and heads once, but if you keep going and keep going, because odds are 50-50, eventually your results are going to pan out to 50%. Does that make sense?
Okay.
So like if you have a large data entry,
The more normalized the distribution becomes.
yeah, exactly. And then the central limit theorem is basically just talking about the shape of the bell curve. Because we know that, did you play with that little graphic thing? No, the graph that we looked at. But anyway, if you have like a small sample from a larger population, like this is what it looked like if you like played with it. Something weird like that. It's going to be like a weird shape. But the more, well, each square represents a data entry, by the way. But the more, data you have, the larger the sample, the more normal the bell curve is going to look in a graph. And that's all the central limit theory, whatever it's called. That's all it is. It's just the relationship between the number of data entries to the shape of the bell curve. That's all it is.
I have a question for you guys. When it asks for question 13, it's saying less than 3.3. Does that change how you put in the equation? Does that make sense? Like, does it change a negative or a positive? Or is it just asking after the graph has been created less? Or like, does that make sense? So when it says less than 3.3, does that change the sign here, or does it just change where you're looking at here? Okay,
Need to
and
find
so
the z-score.
2.56. Okay. And
But
then
it only gives
one
one number.
I know, that's why I just want this to say less than.
Yes.
Especially
Okay.
since it doesn't.
Okay,
So that's your answer.
okay, so so that is it, okay, okay. And then I just do that, and then I get rid of it, which is the same usually. Oh, okay, so it doesn't change the like positive or negative equation, okay, okay. I was just like.
I don't understand like number.
That, and we'll check everything out.
Zero. Zero.
Did you get the last one?
What do you get the
Number 15. Hang on, I need to read over it again.
I don't know, like, I don't know what to do. I just got 0.055.
Because it's asking like the extreme one, what extreme?
Where are you at, Melissa, how are you doing?
I'm stuck on 6.
Okay, go ahead and, let's see. So it's just asking what the z-score is.
Okay, so this is.
So to get the z-score, you take
Find the probability.
score that the person got, the sample score or the probability score, minus the mean score. So it'd be 160 minus 150.8.
But where did you get that? It
So-
only gives one number.
So it says just above question 6 to use the following information to answer the next 4 questions.
Oh, great. I didn't see that.
No, that's okay, that'll help. And then you divide, so after you minus 160, it's okay, I keep having to go back. That's why I actually just use a notebook and I write it down, so I don't have to keep going back up and down and up and down. So what you do is you take 150.8 and put it at the top of the equation. So you go 160 minus 150.8, and you divide it by 8.8. And then that gives you the answer.
Okay.
I need to just start bringing the calculator because my phone doesn't like math. Takes me twice as long.
And the z-score is 3.32.
Nope. I don't think so. Did you go 160 minus 150.8?
Well, I did a typo.
No, that's okay. That's why we do it every day, so we can help.
I think I got it for number 15.
Oh, 5.
Hang on, let me see if I got it right. I'm gonna submit it.
Yep, that's what we all have to. Good job.
Well, I got number 5 wrong. The central limit theorem.
So for 7, I'm actually working on 7 right now as well, so I thought it's the same thing as you. I thought it was asking the same thing, but what it's asking is that to plug in that z-score into the applet
So I wonder what that is if that was incorrect.
above the positive.
That was the only one I got wrong. Number 15? Okay.
Okay, what did you guys take for 7 really quick? I'll find it so we got that one.
7,
Yeah, for number 7.
0.148.
I got 0.296.
Okay, wait, so if I understood you guys right, you took the z-score that you got on the previous question, put it in the applet. And it's asking above 160.
Yes.
So that means it's asking above, so would it be the center and?
What's that number?
Okay, it's number
We'll
7,
score above 160.
which means that it would be the center plus the, no. Okay.
What was your z-score that you got?
The z-score for numbers 6.
7. Well, what
That's it.
z-score did you use, I guess, for number
For
6?
number 6, right?
Yeah, what is it?
1.045. Is that not what you guys got?
Yeah, okay.
Okay, that is what you guys got. Okay. So now you plug it into the applet as the z-score. And then the areas that you pick would be the center,
Mm-mm.
just,
It says above,
so it
right?
would just be the one on the right.
Is it?
Positive.
Mm-hmm.
Got it. It's not the negative.
No.
Okay.
Wait, how did you do that?
What's
It'll only it won't let me do, it
Click
only
on
lets
it.
me
See?
do.
Just click on the area.
Just plug in
I
1.045.
did that, but both
So click on the
sides are
one that you
shaded.
don't want.
Oh, then click on the left side
Yeah.
again.
So then it would be 0.14. Then it's just that section.
Yep.
Throwing me off is that.
Okay, so for number 15,
Yeah, because we have to move, so.
here's the marker. Shoot. I have all these numbers, trying to remember where I got them. Comments.
Yeah. It's 1.
Negative 1.920.
Yes.
And then it was either above or below. So you combine
So
the
answer
two
is
on the applet.
0.55.
So you shade both extremes, but not the middle.
So what do you get?
0.055.
Yeah.
Yeah.
Wait, what's that one from?
The last question.
Yeah, there.
Oh, okay.
Yeah, there you go.
By the way, I got number 6 wrong.
5.
5? Yeah, central
Yeah.
limit theorem.
That was a large.
I really wonder what they were talking about. If that wasn't the right answer.
Is it the law of large numbers?
Should we put put in a different answer? See which
Right?
one-
Let's all put in, yeah. Yeah, I'm gonna copy down the answers right now. I'm really stooped,
Did you
and
get,
it's about time to go.
yes, it is. What did you guys, so did you get everything else right other than that?
Mm-hmm. Yep, it's all correct.
Okay, so for number 9, if I'm understanding it correctly, do I just pick a score that's higher than, a mean score that's higher than the question before and then calculate it? Does that make sense?
What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
Oh. Exceedingly.
Did you get that one right?
I did.
Yeah, number 5 makes sense.
And is how you solve it, you just give a mean score that's higher than the 5, and then you just figure out what that is, right? You just randomly assign a higher mean score. Number 9, because asking if the probability of the 5 randomly selected students have a mean score higher than the ones in the previous problem.
I think you just shade the
Oh.
higher side of the applet.
He was applet's gonna kill me. Okay, all right. Nah, More than less than.
Number 8.
Okay.
Because that Z score was an unusual score, as in it was greater than 2.
Okay. That's true. Okay.
So the probability for, number 9 is going to be really, really low, which it is.
Uh-huh.
So try that and tell me what you get.
So it would just be case
Yeah.
Number 8, and that means so it's 60 minus 60 now over 8.8.
Which question?
8.
Oh, no. It's
Well, no, if it gives 5 minutes,
160 minus 150.8 over 8.8 divided by the square root of 5.
I'm confused.
So here I'm gonna box it on my paper. That's the formula that you should be getting. And the bottom number is the answer.
But where'd you get the square root of 5 from?
That's the sample size.
Yeah, it's one of the equations in the prep.
That doesn't.
A random sample of 5 students. Blah, blah, blah. So like this lesson was the same as last lesson, only we added that extra step of, taking the standard deviation.
Okay, if you go back and look at it, it'll make sense. If you actually watch the videos just for this lesson, it reviews.
It reviews last lesson and just adds
So if you
2 minutes to it.
So if you just watch the videos for lesson 7, it pretty much encompass everything. And it's okay because we're all kind of trying to figure out this new equation and how you utilize it. So for question number 9, the area would be 0097, 0.0097.
Yeah.
Super small. Okay.
Yeah.
All right.
So the new Z score would be 2.33.
Yeah.
Yep.
Yeah, that's
Yep,
the
you
one
got
we
it.
Yeah.
2.338.
My problem is I can't fit everything.
You're talking about your classes?
Yeah.
Well,
Oh, I know. It's a struggle.
right. It's really strong. I was literally
feeling that way
on the
last
way
week.
here. $90 everybody. 90. He actually was just like, next time just use your cruise control, honey. Thanks, officer. Appreciate it. Roll call to the side. From the
So I felt that same way last Thursday. So I kind of got really quiet at the end because I was so mad, like, I'm not getting it. But I don't know, I guess it's different for everyone, but I feel like when you settle into a semester and you realize what you're good at and what you're not, and which classes need more attention and which ones don't, once you figure out how to distribute your time.
You're using stats for it. Stop it.
Well, you know. What I'm trying to say is I realized like I needed to give stats more attention because before I hadn't been. And there were other classes I could pay less attention to and still do really well. I feel like it's working out now, but it was just a week ago that I felt like I couldn't do it all, and that I wasn't gonna get the grades I wanted. And I still may not, but I'm just at least feeling a little better.
I think this is the other reason why she helped us meet.
Yeah.
She recognizes the fact that we're each gonna understand something a little better than the next person.
And maybe it'll like push us in a different way, you know?
For 9, did you get 0.0097?
Yep, that's it.
I'm good at math, it's just I can't fit everything in.
Oh, me too, but like I realized I actually have to learn this.
Same, no,
Yeah.
actually.
Statistics is kind of different.
I'm supposed to have chemistry and genetics and 2 other classes.
Do you have Brother DeWall for genetics?
Yeah,
Do you have
it's
to
a
take them at the
retake, so
same-
it's easier this round.
Do
Yeah.
you have to
But-
take them at the same time? Or do you just, it's just not about time?
I only have 25 credits left, so yeah, I'm out of options.
I'm kind of there too. I literally have fall semester and then 1 class in the winter.
Wow.
And then I'm
If you want. Well, we got to figure out what number 5 is.
So I think that I understand.
Okay.
Say, like, decreases how the sample size increases, so you know, like so because the x and the little thing is the standard deviation, but for the whatever for the and so like if that number is small is because the sample is big, you know.
Uh-huh.
And if the number is like the standard deviation that we get like a large number, so it means that the sample size is smaller. So it's the opposite.
George opposite?
I don't know.
Wait.
I'm really
I
confused.
love how it made sense when she finished saying it.
I want to say I understood what you were saying, but
how to explain
no,
it.
it's
Like I
Okay.
maybe we need to review like the first lesson.
Oh, these names. Borrelia.
But you don't think it's law of large numbers?
Hmm?
Is it law?
It is because
It is law of
like,
large numbers.
Because we're not talking about like the shape of the.
Oh, so the spread,
Yeah, we're talking
how I drew
about-
that graph earlier, and the spread was like here, but as the sample size increases.
Exactly. Yeah. There you go.
Try it. See if you get it right.
So it would be,
We're not talking about left, right, or
it's up and down.
yeah.
So it would be not the same. So it would
No.
be
No, because like that's exactly what I was saying.
Yeah.
law of large.
Yeah.
So, okay, for number 11. I realize I didn't answer that one. Okay, so for number 11, maybe I should just write.
Number
Ugh,
11,
you guys need to go. It's like already like 9:12. You guys need
for
to,
number
like,
11, it's 3.5, and
But it's asking,
yeah, it's asking you the mean. So if you read the
which is just the mean of the population.
yeah, it's 3.5.
It's tricking me because it's saying write your answer.
Yeah. I know.
Okay. Okay. There's no trick here. It really was what you thought it was.
Wait, there's the
Did you finish?
I still have the very last one, but
I can give you the answer right
and
now.
then I will solve it.
Just kidding, it's written right there.
11 and
I
12 aren't trick questions, are they?
What's that?
There's 11 and 12, there's no calculating involved. They're not trick questions.
Just shading, isn't it?
Just looking to see.
Oh, actually, yeah, like the what is the mean? And you're like, where is it? Oh, you find it.
Okay. Just making sure that they weren't trick questions.
Well, let me scroll down and look at it. 11. Yeah, that's the GPA.
Yeah, the GPA. or
Yeah.
the mean and the
So 11 is 3.5.
standard deviation.
Standard
All the
deviation.
numbers just came from the problem.
No, standard deviation, you actually have to calculate that for number 12.
It says it up there though, that it's 10.7.
But it's saying
But it's of the sample.
which is that
So-
equation that he showed you with the square root.
But it's not the entire thing.
Yeah, it's just that bottom part. So it's
Where's the-
0.7 divided
Where is
by
it?
the sample size, which is 81, right?
Oh.
Is that what it's saying for 12?
Oh, we borrowed it?
No, it just says what's the standard deviation.
So how many microbes now do we have? We have 6.
Number
6.
12
So it's
says, what is the standard
Penicillium,
deviation of the
Prosogenum,
distribution
Saccharomyces
of the
cerevisiae,
sample mean
Bacillus
sample
anthracis,
distribution for all
Borrelia
possible samples of
burgdorferi,
81?
Dracunculus
So it's saying you need
medinensis.
to take the standard deviation
Uh,
divided by the square root of the sample size, which they
And there's
gave us
also
as
Coronabacterium
81 in the
diphtheriae.
problem 12. Does that make sense?
I think
Yeah,
that's it.
so
I
it's
think I
just-
said all of it.
It's the regular standard deviation, which is 0.7, divided by the square root of 81.
Yeah, it's a trick question, isn't
For number 12, I'll give you the answer.
it? No.
Something
to
that
try
I
and work
really
it out.
like is when it says the
What?
sample, it means to make sure that it's an
Mhm.
equation, because they'll give you the givens of the whole population, but then the samples are the
Yes.
ones where you require,
So,
Awkward.
so just be careful because sometimes they're gonna ask you for the sample and the sample is just like 5 or 20, but it's part of the whole population.
okay. Alright, so just to clarify, I'm gonna calculate the equation you put up on the board, but all of those just came from the problem 15. It's 2, 6.7, yep, that's the problem. Round sample 48, yep. Then would be sample would be that, yep. And the amount of weight is.
Okay, for 13 and 14, you would need to find the z-score first, right? Before finding the probability.
Yeah, we'll be there in a sec.
So, yeah, so for 13 is, yeah, so it would be, so less than 3.3, so then, yeah, you'd say 3.3 minus the 3.5 divided by the,
Is this how you spell this one?
the new standard deviation that you got from the previous question.
Okay.
So you don't
Borrelia
have to redo that math. It's
burgdorferi.
the
Yep.
Yes.
0.07.
Yeah, that's what I would do. I just write it again and again and again.
So it'd be 3.3 minus.
And it's a
divided by the
spirochete.
0.078. Yeah. And that gives you.
Gram negative.
Your new z-score to put into the applet,
Oh,
and then you put that
Mhm.
in, and then you figure out the area.
Oh, gram negative, and like which is which.
And have the
Is
answer, so
important.
once you calculate it.
So like knowing that Borrelia burgdorferi is a gram negative bacterium is important to know. Yeah. Or that Bacillus anthracis is gram positive.
Are you taking the lab?
Mm-hmm.
Negative 2.3.
Negative 2 point, I got negative 2.56. Did you make sure that it was 0.078?
Which z-score is that?
It's the one that she needs to have for the, probability. I'm like jumping back and forth. Yeah, the probability, so
Right.
take 3.3 minus, so it's 3.3 minus 3.5.
BYU Idaho students will be less than 3.3.
Yeah, go ahead and do that first, so 3.3 minus 3.5, and then equal it, and then say divided by 0.078.
Negative 23.
Clear your calculator again, I think your calculator's arguing with you.
3.3 minus
Minus.
3.5,
Equals
close parentheses, divided by
0.078.
0.078,
No.
Yeah, that's right, that's right.
Yeah, sorry, I don't ever put it.
divided by square root of 81.
No. So you don't have,
That's the sample size.
yeah, but you already did that. See, look.
So this is my formula.
See, this is this answer, so instead of me putting this back into here, I just use that answer. So you just have to do that.
2.5 negative.
Yeah. So then you just put that into your applet. Yeah, so you knew what you were doing. We were just all telling you everything at once.
Bless you.
And then you would just highlight the one side of it. And, yep, that's right. 0.0052. Yep, that's right.
And this concludes this session.